Good afternoon to everyone. So today, I think last class we discussed solving system of differential equation. I think I solved three problems, and also I posted three problems for practice and with the answers. So practice at least those three problems. Now I'm going to the next section, method of variation of parameters. Method of variation of parameters for second order differential equation. For second order differential equations. So usually when we discussed type 1 to type 7, the type 7 column, for example, the right hand side function is secant ax or tan ax or cosecant ax. Okay, then I told that we cannot solve those problems under type 1 to type 6. So if you cannot solve the problems from type 1 to type 6, you should choose type 7, and then you should use the formula that 1 by d minus m into capital X is equal to e power minus mx into integral e power mx into capital X into dx. Okay, so now at the same time I told that we can also solve these type of problems in type 7, or one more method, that is the method is called method of variation of parameters. So now we will solve those type of problems in using method of variation of parameters. Okay, consider uh, general equation, general second order differential equation, a naught into d square y by dx square plus a1 into dy by dx plus a2 into y equal to capital X. Capital X is a right hand side function where a naught comma a1 comma a2 and a naught is not equal to 0 are constants. So then CF, you know how to find CF. C1 into F1 of x plus C2 into F2 of x, where C1 and C2 where C1 and C2 are constants, are arbitrary constants, and F1 and F2 are functions of x. Functions of x. Now, using F1 and F2, we are going to find PI, particular integral. Particular integral equal to capital P into F1. F1 is this function plus capital Q into F2, this function. So what is capital P? What is capital Q? Where capital P equal to minus integral F2 into cap divided by uh, uh, Wronskian of F1 comma F2. Usually we will say like this. Okay, W of F1 comma F2. W of F1 F2 means Wronskian. Okay, so I think you can see this word in crazy book. Okay, so that is a denominator Wronskian of F1 comma F2, that is F1 into F2 dash minus F1 dash into F2. This is the Wronskian of F1 comma F2 into dx, and the Q is integral F1 into capital X divided by F1 F2 dash minus F1 dash into F2 into dx. So after getting Pi, now the general solution is general solution is as usual y is equal to Tf plus P. So only thing here integration is involved. So you know uh, how to integrate this function. Okay, wow. So once you got the P and Q, you can easily find the PA. The first problem, solve d square plus 1 into y equal to cosecant x into cot x. Using method of variation of parameters. Method of variation of parameters. The solution. So first you should write the auxiliary equation. So auxiliary equation is m square plus 1 equal to 0. So m square equal to minus 1. So this implies m equal to plus or minus I. So then complementary function is C1 into cos x plus C2 into sin x. Okay. Now let us take F1 equal to cos x and F2 equal to sin x. Okay. Now find F1 dash is minus sin x and find F2 dash cos x. So I need to calculate the denominator in both P and Q. That is Wronskian of F1 comma F2 is F1 F2 dash minus F1 dash into F. That is, you should multiply these two minus you should multiply these two. Okay. So then F1 into F2 dash, that is cos square x. Here have minus. minus sine square x. So minus to minus plus equal to 1. So the denominator is 1. Okay, now we should try find p. P equal to minus f2 into capital X divided by the denominator f1 f2 dash minus f1 dash f2 into dx. So f2 is sin x, x is the right hand side function cosecant x into cot x. The denominator is 1. Okay, so p equal to minus integral f2 is what? Sin x into capital X is cosecant x into cot x. Denominator is 1 into dx. So cosecant x sin x gets cancelled. So remind you have integration of minus cot x into dx. This is minus integration of cot x is log of sin x. So this is actually p. Okay, next we should find q. Q equal to q equal to f1 of f1 into capital X divided by uh, into dx divided by Wronskian of f1 comma f2, that is f1 into f2 dash minus f1 dash into f2. Okay, now this is equal to integral. What is f1? F1 is cos x into capital X. Capital X is the right hand side function. Cosecant x into cot x. Denominator is 1 into dx. This is equal to integral. Here, this is cos x, this is 1 by sin x. So cos x by sin x. Cot x is also cos x divided by sin x into dx. Denominator is 1. So integration cos square x by sin square x into dx. Write the numerator in terms of the denominator. So that's why I am going to write cos square x is 1 minus sin square x. So integration of 1 by sin square x is integral cosecant square x into dx. Sin square x by sin square x is 1. So integration dx. Integration of cosecant square x is minus cot x minus integration of dx is x. This is q. Now pi equal to p into f1 plus q into f2. So what is p? What is f1? F1 is sin x, sorry, cos x. F1 is cos x. What is p? P is minus log of sin x. P is minus log of sin x. Okay. And then what is f2? F2 is sin x into q. Q is minus cot x minus x. So pi equal to minus cos x into log of sin x uh, minus, you can write cot x is cos by sin. Okay, so sin gets cancelled, so minus cos x minus x into sin x. This is minus cos x. Okay, okay, minus x into sin x. So now finally write uh, the general solution y. The general solution y is CF. CF is, please check it, C1 cos x plus C2 into sin x, and then Pi minus, I think you can combine these two. I'll take minus cos x commonly. If I take minus cos x commonly, 1 plus log of sin x, 1 plus log of sin x, and then minus x cos x, x sin x, minus x sin x. So this is the solution for the first column. So if you have any doubts in the first column, you can ask to me. Okay. Second problem. So I am expecting somebody should solve this problem and tell the answer before I am solving. Okay. So I am expecting the answer from your side, but I am also I also do it, but I will do slowly. So try to do little bit fast and then tell the answer. Solve by method of variation of parameters. D square y by dx square plus 2 into dy by dx plus y equal to e power minus x by x square. The solution. So first you should write the auxiliary equation. So before that I will write like this: d square y plus 2 dy plus y equal to e power minus x by x square. Okay. So or d square plus 2d plus 1 into y equal to e power minus x divided by x square. So now the auxiliary equation is m square plus 2m plus 1 equal to 0. This implies m plus 1 whole square equal to 0. This implies m equal to minus 1 comma minus 1. So the roots are real and the repeated roots. The complementary function is c1 plus c2 into x into e power minus x. Okay, or you can write EF equal to C1 into e power minus x plus C2 into x into e power minus x. So f1 equal to e power minus x, and f2 equal to x into e power minus x. As usual, you should find uh, f1 dash, that is equal to minus e power minus x, f2 dash, UV method. So keep x, if you differentiate e power minus e power minus x plus e power minus x. So f2 dash equal to minus x into e power minus x plus e power minus x. Okay, now we need to calculate f1 into f2 dash minus f1 dash into f2. Multiply these two, multiply these two, put a minus sign. Okay, so if you multiply here, you'll get e power minus x into minus x e power minus x plus e power minus x. And then minus sign, minus of minus plus, so plus e power minus x into e power minus x. So this is equal to minus x into e power minus 2x plus e power minus 2x, e power minus x into e power minus x, e power minus 2x plus x into e power minus x into e power minus x, e power minus 2x. So you can cancel minus x into e power minus 2x plus x into e power minus 2x. So you only have only e power minus 2x. So this is the denominator. Now capital P is minus integral f2 into capital X divided by the denominator f1 f2 dash minus f1 dash into f into dx. Okay, now what is f2? f2 is x into e power minus x. Capital X is a right hand side function, that is e power minus x by x square divided by the denominator is e power minus 2x. Just now we got it into dx minus integral. Here have x, here have x square. Okay, so the denominator is 1 by x. The numerator is what? E power minus 2x divided by e power minus 2x. X divided by x square is x into dx. So minus e power minus 2x, e power minus 2x gets cancelled. You have minus integral dx by x. This is minus log x. So p equal to minus log x. And what is q?
Minus 1 by x.
Minus 1 by x is correct. Good. Okay. What is the final answer? PI.
Minus e power minus x into log x plus 1.
Yes, correct. Good. I think some of you solving independently. Okay. What is okay? Good. So now q equal to we need to find the integral f1 into capital X divided by denominator is f1 f2 dash minus f1 dash into f2 into dx. Okay, so this is equal to integral. What is f1? F1 is e power minus x. The capital X is e power minus x by x square. Denominator is e power minus 2x. So here also you have e power minus 2x, here also e power minus 2x. So just you have integration dx by x square. So this is equal to minus 1 by x. So q equal to minus 1 by x. So pi particular integral equal to p into f1 plus q into f2. Okay. What is the p? P is minus log x. F1 is e power minus x plus q is minus 1 by x. F2 is x into e power minus x. So I will take minus e power minus x commonly. Remaining is log x, xx gets cancelled. So minus e power x is also I take common. So remaining is plus 1. This is a particular integral. Now the general solution y equal to cf plus pa, that is c1 plus c2 into x into e power minus x minus e power minus x into log x plus 1 or 1 plus log x. The third problem, so try to find the solution for this problem also. Solve d square y by dx square minus y equal to 2 divided by 1 plus e power x using method of variation of parameters. You don't write MVP, you should write method of variation of parameters in your note. Solution d square minus 1 into y equal to 2 divided by 1 plus e power x. So write the auxiliary equation. That is m square minus 1 equal to 0. So m square equal to 1, m equal to plus or minus 1. The complementary function is c1 into e power x plus c2 into e power minus x. Okay. So now f1 is e power x and f2 is e power minus x. f1 dash is equal to e power x f2 dash minus e power minus x. Okay. So now I need to find f1 into f2 dash minus f1 dash into f2. So minus okay, minus e power x into e power minus x minus e power x into e power minus x. So this is equal to minus 1 equal to minus 2. Okay, now find p minus integral. So f2 into capital X divided by f1 into f2 dash minus f1 dash into f2. So which is equal to minus integral f2 is e power minus x. Right hand side function capital X is 2 by 1 plus e power x divided by the denominator is minus 2 into dx. So minus minus gets cancelled, 2 gets cancelled. You have e power minus x divided by 1 plus e power x. Or you can write this is integral 1 by e power x into e power x into dx. So let us take t equal to e power x. Dt equal to e power x into dx. So this implies dx is equal to dt by e power x. I need everything in terms of t. So dx is equal to dt divided by e power x is t. Now, so this integral is equivalent to integral 1 by dx is what? Dx is dt by t. Dx is dt by t. E power x is t into 1 plus e power x is t. Okay. So this is equal to integral dt by t square into 1 plus t. So now using partial fractions, split the function 1 by t square into 1 plus t. Which is equal to a by t plus b by t square plus c by 1 plus t. So now this is equal to 1 equal to throughout multiply by t square into 1 plus t, you will get a into t into 1 plus t plus b into b by t square you have, so b into 1 plus t plus c into t square. Now if you substitute t equal to minus 1, this is 0, you can find c. So 1 equal to the c into minus 1 whole square. This implies c equal to 1. Similarly, if you substitute t equal to 0, this term is 0, this term is 0, first and last 0. So 1 equal to 0 plus b plus 0, this implies b equal to 1. Okay, now compare the coefficient of t square. Compare the coefficient of t square. The left hand side you have, there is no coefficient of t square, that's why 0. Here if you multiply these two, at into t, that is a t square, the coefficient is a. If you multiply at into a1, at, so I don't have t square. Similarly here I don't have any coefficient of t square, so here I have t square, so a plus c. But we know that the c equal to 1, so this implies a equal to minus 1. So now 1 by t square into 1 plus t, which is equal to a. A is minus 1 by t, b is 1 by t square, c is 1 by 1 plus t or t plus 1. So now using this, this integral. Actually, what is this? Actually, P. P. This is actually P. P equal to integral dt by t square into 1 plus t. So P equal to, if you split the function, you will get what? Integration minus 1 by t plus 1 by t square plus 1 by t plus 1 into dt. Okay, now we should integrate. Okay, so minus log t, integration of dt by t. Okay, now next integration of dt by t square is minus 1 by t plus integration of dt by t plus 1 is log of t plus 1. So log a minus log b, we can write log of a by b, log of t plus 1 divided by t minus 1 by t. This is actually p, but what is t? T is e power x. So e power x, so log e power x plus 1 divided by e power x minus 1 by e power x. So this is p. Okay. So now we need to find the q. So anybody got q value?
Log of 1 plus e power x.
Log of 1 plus e power x. Minus
Minus log of minus log of
minus log. Okay. Minus log of 1 plus e power x is correct. So then you can easily find the final answer. So q equal to integral f1 into x divided by the denominator f1 into f2 dash minus f1 dash into f2 into dx. f1 is e power x. Uh, capital X is 2 divided by 1 plus e power x. The denominator is minus 2. So which is equal to integral minus 2 to gets cancelled, minus e power x by 1 plus e power x into dx. So if you differentiate the denominator, you'll get the numerator. So that is the form of integration. F dash of x by f of x is equal to log of f of x. So that's why q equal to minus log of the denominator. Denominator is 1 plus e power x. So now Pi equal to P into F1 plus Q into F2 plus Q into F2. Okay. Plus Q into F2. So what is P and what is F1? Okay. F1 is P. First to write P. P is okay. This is P log of 1 plus e power x by okay, log of 1 plus e power x by e power x minus 1 by e power x. So P into F1. F1 is e power x plus Q. Q is minus log of 1 plus e power x. Okay. And F2. F2 is e power minus x. Please check it. So now if you simplify, you'll get e power x into log of 1 plus e power x divided by e power x minus 1. E power x gets cancelled, minus e power minus x into log of 1 plus e power x. So the final answer is y equal to a complementary function plus particular interval. So please rewrite here CF and PA again. So I think the method of variation of parameters is over. Uh, Now I will give some practice problem to you. First problem, y double dash plus minus 2y dash. This is y dash plus y equal to minus e power x into sin x. So solution is y equal to minus x cos x plus sin x plus c1 into e power x plus cos x plus c2 into x into e power x. Second problem, solve y double dash minus 4y dash plus 4y equal to e power 2x by x. The solution is minus x plus c1 into e power 2x plus log x plus c2 into x into e power 2x. Okay, so still have remaining, okay, I'll write it. Nice. Y double dash minus 4y dash plus 5y equal to e power 2x sin x, e power 2x by sin x. Answer is y equal to e power 2x into c1 cos x plus c2 sin x minus x into e power 2x into cos x plus e power 2x into sin x into log of sin x. Fourth column, y double dash minus 2y dash plus 2y equal to e power x into tan x. The answer is, so y equal to e power x into c1 cos x plus c2 into sin x minus cos x into log of secant x plus tan x. Okay, and last column. This is a variable coefficient. Up to fourth column, constant coefficient. square d square y by dx square plus x into dy by dx minus y equal to x square into log x so y equal to c1x plus c2 divided by x plus x square by 9 into 3 log e minus 4. The next section is orthogonal trajectories. Okay. So after orthogonal trajectories, application of differential equation. So there are 4 applications, I think so. So nearly we are ending to second unit. Okay. So orthogonal trajectories, two families of curves such that every curve of either family cuts each curve of the other family at right angles. Okay, so they are called orthogonal trajectories of each other. So two curves are orthogonal. Okay, so y equal to f1 of x and y equal to f2 of x. The two curves are orthogonal. Then when we say that the two curves are orthogonal, if the slope m1 into m2 equal to minus 1, then you will say that the two curves are perpendicular or orthogonal. Here, there are two families of curves, not a single curve. Okay, so in each family you have so many curves. Okay, so there are two families of curves such that every curve of either family cuts each curve. Okay, cuts each curve of the other family at right angles. So then we say that they are orthogonal trajectories of each other. Okay, orthogonal. Okay, there are some of the uh, application side or engineering side problems. Okay, so especially mechanical students and electrical science students will study maybe in the second year. Okay, or even, okay, I think they will study maybe in the second year. Maybe they will study in the second semester also. I don't know exactly. The path of an electric field is perpendicular to equipotential curves. Okay, and in fluid flow, the streamlines and equipotential lines are orthogonal trajectories. The lines of heat flow is perpendicular to isothermal curves. So these are the some of the examples of orthogonal trajectories. Maybe you will study in the upcoming semesters. Okay, so again, it's this is the definition of isogonal trajectory. A trajectory of a family of curves is a curve which cuts each member of the family at a given angle. This curve is called an isogonal trajectory. And I already explained you what is orthogonal trajectory. An orthogonal trajectory is a curve which cuts each member of the family of curves at right angles. Okay, so this is a definition of self-orthogonal. A given curve, a given family of curves is said to be self-orthogonal if the family of orthogonal trajectory is the same as the given family of curves. So then we say that the family of curve is self-orthogonal. So here, it's a note. Suppose the curve is given f of x comma y comma z equal to 0, then in Cartesian form, the slope is dy by dx. Similarly, the curve is the given curve is in this form, f of r comma theta comma c. Here c is a parameter. okay, is equal to 0, then the slope, the polar form. In polar form, the slope is equal to r into d theta by dr. Okay. So now working rule to find the orthogonal trajectories. This is a working rule for, suppose the given equation in the Cartesian form. Okay. So the first step is by differentiating the equation of curves, okay, with respect to x. By differentiating the given equation of curve with respect to x, and find the differential equation in the form f of x comma y comma dy by dx, and then replace dy by dx by minus dx by dy. Okay, so you should replace dy by dx by minus dx by dy. That is m1 into m2 equal to minus 1. Uh, Solve the differential equation of the orthogonal trajectories. So once you replace dy by dx equal to minus dy by dx by dy, and you should solve the corresponding differential equation of the orthogonal trajectory. So these are the three steps. These three steps is a little bit elaborately given here. So working rule to find the equation of orthogonal trajectories, a Cartesian form. So the form is f of x comma y equal to 0. This is equation 1. Differentiate equation 1 and eliminate the arbitrary constant. Otherwise, we call, sometimes it is called parameters between equation 1 and the resulting equation. So first thing, we should differentiate with respect to x and eliminate the arbitrary constant or the parameter from the equation 1 and the resulting equation. That will gives the differential equation of the given family. Given family is 1. Once you got the differential equation of the given family, that is the form x comma y comma dy by dx, you should replace dy by dx by minus dx by dy. So that is the differential equation of the orthogonal trajectory. So therefore, the differential equation of the orthogonal trajectory is f of x comma y comma minus dx by dy equal to 0. So actually equation 3, if we solve the equation 3 to get the equation of the recurved orthogonal trajectories. So this is the procedure when the given equation is a Cartesian form. Suppose the given equation is the polar form, differentiate equation 1 with respect to theta, and eliminate the constant c from 1 and the resulting equation. The resulting equation means the equation which you got by differentiating with respect to theta. That is the resulting equation. Once you eliminate the constant c, uh, that gives the differential equation of the family of equation 1. Okay, so the differential equation of the family of 1 is f of r comma theta comma dr by d theta equal to 0. Now we should replace dr by d theta equal to minus r square into d theta by dr, not just by minus 1 by r into d theta by dr. Okay, so you should replace dr by d theta by minus r square into d theta by dr. So once you replace like this, the differential equation of the orthogonal trajectory is f of r comma theta comma minus r square into d theta by dr equal to 0. So now if you integrate equation 3 to get the equation of the recurved trajectories. So this is the procedure. I think now time is nearly 1 o'clock. So I think we will discuss problems in the next section, next class. Okay. I think still we have three or 4 minutes. I don't want to rush up the problems now, because at least I need 10 minutes for the first problem. I think you understand the concept clearly. If you have any doubts in the orthogonal trajectories or method of variation of parameters, you can ask to me. I think yesterday I posted some of the mistakes in the assignment problems also. Okay, especially in problem 11, there is a mistake in the answer. Okay, but I forgot it, the remaining thing. Okay, and the problem 3, I don't know exactly. Please check the our WhatsApp group message. And Karthikeyan also asked one doubts yesterday. I think in problem number 3. Karthikeyan, are you got the answer or not?
Yes, sir. Got it, sir.
Okay, good, good. Okay, so I think remaining students are trying to solve assignment problems. So try yourself and discuss with your friends. So if you don't get it, okay, after discussing with friends also, you can contact me. I will help you. Okay, thank you. We'll meet again tomorrow, 7th hour.
Thank you, sir.
Thank you. Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Sir,
Yeah, Sarvesh, சொல்லுப்பா.
sir, method of variation of parameter செகண்ட் ஒர்க் அவுட் பண்ணுவாங்க சார். அது டைப் 4 லைன் ஒர்க் அவுட் பண்ணுவோம்.
இது ஒரு நிமிஷம் எடுத்துக்கிறேன்.
எஸ் சார்.
டைப் 4 டைப் 4ல டினாமினேட்டர்ல வந்து ஒன் எக்ஸ் ஸ்கொயர் இருக்கு. அது நியூ ஓகே, அதை வந்துட்டு நியூமரேட்டர்ல இருந்து போயிடுறியா எக்ஸ் ஸ்கொயர், அல்லது அப்படியே வச்சுக்கிறியா?
எக்ஸ் பவர் மைனஸ் 2.
எக்ஸ் பவர் மைனஸ் 2 வச்சுக்கலாம். ரைட்டு, ஓகே. பிகாஸ் த ரீசன் வந்துட்டு இப்போ எக்ஸ் பவர் மைனஸ் 2 ட்ரை பண்ணி பாரு. பட் த ப்ராப்ளம் இஸ் think the reason why I'm a little bit okay. Suppose if you write this is a d plus 1 whole square, வரும்போது
Yes, sir.
d plus 1 whole square, d plus 1 whole square. If you take it to the numerator, 1 plus d square whole power minus 2 in PI. I'm telling in PI.
Yes, sir.
Okay, va. PI. Right hand side is 1 plus d square. First, okay. Actually, first
E
we
power
should do
minus.
like this. 1 plus d square into e power minus x into square. So if you, sorry, 1 by x square. Okay. So if you replace e power minus x by d by d plus 1, d minus 1.
Yes, sir.
D minus 1 plus 1 whole square. So 1 by x square. Okay, so I think this is equal to e power minus x by 1 by d square. Okay, so you should integrate twice. So
Yes.
okay, if
Question
you
method.
integrate method வந்துட்டு if they gave method of variation of parameters, you should use method of variation of parameters only. Just to
Okay,
solve means you can use any method. Okay, thank you.
Yes.
Thank you,
Yes, sir.
Sarvesh. Thank you for the question. Okay,
Thank you, sir.
thank you.
Thank you, sir.
Thank you, Dineshwar. Thank you.